Hi and welcome to our webinar. Today we are going to talk about water. And my name is Lena. I work at Cobra Systems as a fire engineer together with my colleague.
Yep. Hello, I'm Daniel. I work with Lena. I work with mainly the training courses and also to develop the Cobra method.
And why are we going to talk about water today? It's because of it's a constant debate about the environmental impact from fires. And it's a complex relationship between the fire and the environment, as well as the extinguishing method.
Mm-hmm.
And we believe that the actions of emergency service, they have both a local and a global environment impact. And the fire and rescue services are required to have knowledge and understanding of the environment's consequences of different tactical choices in active response.
Yep, and we're going to talk about both the aspects from Sweden and also from England. How it's dealt with in other countries, we're not too sure. So send your information in, please, if you have it.
Perfect. And today's agenda, we are going to briefly talk about the impact from water runoff on the environment, and then how the legal implications affect how you choose to fight fire, and as well talk about water usage and runoff, and define what water runoff actually is, and then what Cobra can offer or how we can contribute to a more efficient firefighting.
Yep.
And more environmentally friendly.
Right, shall we start?
Yeah.
Okay. So if we look at this picture, it's written in Swedish, so we really only need to look at the pictorial part of it. The words I'll explain to you. But if we consider the fire, the house fire that's happening on the picture, then there will be some direct runoff from the fire that goes into the soil, into water systems. But then if we follow the bottom red line, we can see that even if it goes into the drains, it's going to end up at the sewage works where they clean the water. And also when we go back to the fire station, you can see the line above, the red line above, that even when we clean our equipment and our hoses, it's also going to end up at the sewage works. They in turn will release some of the water into water streams or lakes. Some of the what's left over is then used by the farming industry as fertilizer. So that then goes into the food that we eat, as you can see from the arrow on the left-hand side. So this is a global issue. We can't avoid it. Pollution that's created in Sweden is going to affect people in other parts of the world, and pollution that's created maybe in Asia is going to end up in Sweden. So it's something we really should work with to try and reduce the amount of water runoff we have from fires, to make it as clean a process as possible. It's a huge challenge, but we really should try to put our efforts into doing this. Okay, Lena, this number 10, what does this mean?
So this means that we can say that 10% of the water used when fighting a fire is used effectively, and 90% is excess water, meaning that we can't control where it ends up. Either it ends up destroying the property as water damage, or it will go into our drainage, as you showed just in the picture before.
So when I see this, I think it's very hard to regulate, because you're a fire engineer, you're the smart one, and it's very theoretically we can work out exactly how much water we need to extinguish a certain size of fire. But if you are a firefighter, we can't be that exact. But we can be a little bit more thoughtful as to the method we choose and the tactics we choose. And certainly during the time I worked as a firefighter, that wasn't really discussed.
Right.
How much water we use. And if the house got damaged or if the cellar was filled with water, you know, it wasn't really our problem.
No.
But quite clearly, we can be better at reducing this amount of excessive water.
Mm. So what has the weight of justice to do with this?
Oh, the picture of the scales on the right-hand side is just to create this discussion about we obviously want to extinguish the fire. We want to make sure the fire services and their personnel are safe, but we also want to use the water effectively. And how can we do that?
Right.
Use of water against safety and actually being able to extinguish the fire.
Mm-hmm.
Number 50 then.
Number 50. Well, this is you who talked to a major insurance company.
Yep. Yeah, because I was interested with this question. So there's an insurance company in Sweden called Håkansson, which is one of the major insurance companies, and I just asked the question: how much damage at a fire is caused by the fire and the flames and the smoke, and how much is caused by water? And they said to me, roughly 50%. So 50 is the fire and 50% is the water damage. And yeah, I thought that's also a figure we can work with. There's definitely ways to reduce that figure, because it's an enormous cost to society and to us as individuals. So it's quite a large figure, but that's the facts we got from the insurance company. And the picture we can see now is from an article that was written in one of the trade papers in Sweden, one of the firefighter magazines. On the left it's in Swedish, but what was this article actually about, Lena?
Well, this is an article about the environmental code called Miljöbalken in Sweden. And the author has written from the fire and rescue services point of view, raising what paragraphs the fire and rescue services in Sweden has to
Adhere to.
Thank you. And in the bold, it says, the bold to the left, it says that just like in all other areas, the fire and rescue services has to tag along in the development. And I believe that's true. We will talk to Bernie Higgins later on, who's in the United Kingdom, and he is going to tell us about how it used to be. And you also told us how it used to be. You used to have use a lot of water and really not think about how it would affect the environment. And I believe this is a very a good debate that is going on today of how we will take care of the excess water from fighting fires.
Now, it's been discussed for, I remember hearing it maybe 25 years ago, if I guess, but it was just something that was mentioned, but no one really took it too seriously. So we're going to speak to Bernie, and we're going to get his views about the situation in the United Kingdom. That was the situation in Sweden. And now we're going to have a discussion with Bernie Higgins about how they approach this issue in the United Kingdom. Hello, Bernie.
Hi, Bernie.
Hi, Lena. Hi, Scotty. You both okay?
Yep.
Good. A quick intro, because I know you know me, but other people might not. I'm Bernie Higgins. I now work usually as a consultant. I do a lot of work with fire and rescue service equipment suppliers. I chair a council for them. I'm also chair a committee for British standards for fire service equipment, and I work at Colcut, working with the Colcut Academy as well, which is how, of course, I know you both. Before I did all this, really my working life's been steeped in the fire service, because I was in the London Fire Brigade for 35 years, all bar a couple of months, and worked at various levels up to principal officer in London Fire Brigade as well. So that's just a bit of my background for people who are listening in.
Good. Thank you. You've done a lot of things, Bernie, in your time.
I have, yeah. I'm old, is what I'm really saying.
But so what the webinar today is about is sort of water, the environment, and water runoff, and how we can improve this. We've spoken about the Swedish law. What is there in the UK for the fire services to consider when talking about this subject, and even working practically an incident?
Sure. Well, to start with, we work to environmental protection regulations, which I believe, I'm not 100%, but I believe were 2010. And they place duties on all sorts of bodies about not allowing pollutants to get into water courses, into the atmosphere, etc. Because of the damage that obviously they can do both to human health, but also to plant life, to the ecosystem and microsystems. So there is a legal requirement in the UK to be aware of that and to protect the environment as much as you can. Now, with the fire service, obviously, regardless of where you are in the world, the fire service is usually responding to fires and other incidents that will generally cause some pollution. And it's how we go about protecting that and dealing with that, which is key in the legislation. I'll talk about that a little bit more, but probably the piece of guidance that's most relevant here is what we call national operational guidance. So in the UK, we will take key risks. So national operational guidance in the UK is what I would call a risk assessment, a high-level risk assessment for various incident types, various premises types as well. Wherever there's a risk to firefighters from their work, there is some national operational guidance. So the status of that is it's something that fire services should be aware of and should base their own policies and procedures around. So the guidance itself is quite high level, and it allows fire services, therefore, to translate that into what works for those locally around the UK, because obviously we've got big city fire brigades like London and Manchester and West Midlands, etc. And we've got some more rural and sort of more remote fire services in counties where they don't have such big city areas.
So the guidelines they're adaptable, Bernie. You can say
they have to be adaptable, Scotty. Yeah, that's the word I should have used. Really, they're adaptable for all, but they're not legally binding. But in the event that there was some sort of incident where an inquiry, or indeed even a legal proceedings were started, they would be taken into consideration, and a fire service that hadn't taken national operational guidance into consideration would need to provide a clear rationale for why they didn't and what they did instead of it. So you can't ignore it completely, really. You've either got to work with it and adapt and have your own procedures, or you can do something totally different, but it still has to meet the law. The important point here is that fire services must operate within the law.
Okay, and there is a specific national operational guidance for water runoff.
Yes, there is,
which we've read.
Yeah.
There's 5 different recommendations or areas that they talk about in ways that we can control this water runoff, and they're to let it burn, as you said, controlled burning. We can try and contain it. We can recycle it. We can reduce it, and we can try and dispose of it. So there's lots of different ways we can try and work with this. But what's the attitude at the moment, do you think, with fire services?
I think it's changed, Scotty. So when I first became a firefighter, way back in about 1980, in fact, we never really considered the environment. We just focused on putting the fire out. But things like the big laws in the UK hadn't really embedded in the fire service then. So health and safety was a consideration, but wasn't the ultimate. And neither was indeed environmental protection. So we focused on putting the fire out. We didn't tend to worry too much unless it was obvious about what damage we may do to the environment or water courses. So that's changed since, I can't remember the year it was, but the fire service nationally brought in what we call hazardous materials and environmental protection officers as a specialist role amongst officers. So they're also known by initials as HMEPOs, but these environmental protection officers can be called on to any incident to offer advice and guidance about how to protect the environment. So it is taken a lot more seriously and has been for a little while now, and it's only going to get more important as we realise that environmental protection has been for many years, but is now really at a crucial stage.
I think the first one was to have a controlled burn.
Yeah,
and that's a tactic that's used all over the world, I think. But the others, what they're really about, the containment, the recycling, the reduction, disposal, is about actually collecting the water.
Yeah.
I mean, what do you think? Is that practically possible?
It's difficult. There's two things it relies on. Number one, you must have a good operational plan. So every good firefighter should know the patch they work in and know it quite well, and they should know the risks. That's not a UK thing, that's a worldwide thing, but good professional firefighters know the area they work in, or should do, and should know the risks, and that includes environmental risks. So operational pre-planning here is key. So you should be thinking about, when in the pre-plan, if we have a fire in this particular place, let's take, I had a fire in a chemical factory. Fortunately, it was in an urban area, not near any watercourses, but that had an operational plan about controlling smoke and controlling runoff even there. So you have plans in place that you have to be aware of those and make sure you work broadly to the plan. So the planning is really important. Actually doing it for real at the scene is really quite difficult. It can be done. It needs a lot of thinking about, but of course you've got a lot of priorities. When you're the first incident commander, you've got to think about life risk, property risk, risk to human health, etc. You've got an awful lot of competing priorities to weigh up between, your tactics, and you've got to make that weigh up and tactics really quick time. You haven't got 5, 10, 15 minutes to think about things before you start committed cruising. So I have to say, would containment be the very first thing that most officers would think about? Probably not, depending on the circumstances. They would probably want to deal with the fire and do any life-saving activity. But very shortly after, it becomes how do we contain? Now, of course, the guidance, the national operational guidance, gives a number of ways that can be done, using booms, using diverters, diverting the water into foul sewage containers, etc. But in practice, that again needs a bit of planning and takes time. So you have to size up the incident and think, how big is this incident? How much water am I likely to use? How much, therefore, is likely to run off? And do I need to contain? And where can I reasonably contain it? Of course, it's best to contain it as close to the source as you can. But again, as you say, Scotty, that's not an easy thing to do. Sometimes you have to allow it to find a reasonable place to collect it. And there will be the issue about who pays for the disposal, because you can't just ask anyone to come and pick it up. They usually get specialist disposal companies will come and if you create a portable dam for it, for example, they'll come and suck the contents out of that and take it away for specialists, for dealing with it in a specialist way.
I mean, when I speak to you, the thing that strikes me is this is an enormous subject, or an enormous challenge for fire services and everyone else involved, like the environmental companies, the water companies. We haven't got the time that we're going to solve it all today.
No.
But the one thing that the couple of things that I'm hearing from you is planning, very important. You've spoken about that, and also your accountability and be able to justify your decision. Has there been any sort of legal issues around this in the UK?
I'm not aware of any big legal cases around environmental protection so far. That doesn't mean they won't happen, but I'll give you one good example. Back in December 2005, the UK had a massive fire in an oil storage depot in a place called Buncefield in Hertfordshire. And it was one of the biggest peacetime fires we've seen up until quite recently. And basically, one of the oil container, one of the tanks, huge tanks containing oil, it served areas like Heathrow Airport. So it gives you an idea. It was a range of large tanks. One of them exploded, causing a massive fire and, of course, devastation in the area. And the fire service, as a fire service would, turned up and began to deal with that fire by using foam. Now, there's quite a continuing issue around firefighting foams and the effect they have on the environment. And at that incident, there was an issue with the Environment Agency saying, actually, we think we might prefer you just to let it burn itself out. However, the smoke plume contained oil and petroleum products and was leaving an oily film everywhere, and was actually drifted out to the continent because it was being carried on prevailing winds. So it was drifting over towards France and Belgium. So it was causing potential health problems across a significant area. And in the end, that was the justification and rationale. The fire service and the emergency service responders met, discussed it, and decided that actually the best course of action was to put it out because the risk to human health was greater than the risk to pollution. However, they still had to try and collect and contain the foam runoff to stop as much of it as possible from going into normal drains. So finding ways of diverting it into sewers, etc., and foul drainage areas, but also collecting it to be taken away. Okay. So that's a good example, really, Scotty, but I'm not aware of any legal ones. Sorry, Lena.
No, I just said it's a great example.
Thank you. So there's 3 areas in UK law. I'll read them out because I can't remember them. Unfortunately, I'm that old. There are 3 areas, all of which must be in place in the UK if you want to defend the actions of the fire service having done something and not necessarily prevented pollution entering or pollution in the local area. So number 1, any discharge made an emergency must be because it avoids a danger to human health. So that's the first criteria. So that we've allowed the water to run off because we were more concerned about human health. The second one is that the person takes all steps as were reasonably practicable for minimising pollution. So that's a real key term, reasonably practicable. So we should be taking steps, as they did in Buncefield, to try and sort of contain the water runoff as best and the foam as best they can, and try to limit the use of foam where they could, so they didn't to minimise the pollution subsequently. And the final one of the 3 is that particulars of the acts were furnished to the regulator as soon as reasonably practicable after the pollution occurred. In other words, that we would tell the Environment Agency, for example, as soon as possible, we've had this incident, we've carried out these actions, and there was a risk to human health, but some of the pollution has entered the watercourse. If you do all 3, that would be considered to be a defence, but that defence is still, of course, legally challengeable. So even with that, we're still obliged to abide by the law.
All right.
Okay. As I said, there's quite a very complex subject, but I think the thing you've just been talking about is about what's reasonable. You know, if were your actions reasonable and defensible?
Yes.
And then it shouldn't be a problem for the fire services.
That's in a nutshell, Scotty. That's exactly it. You have to be able to have a rationale for why you have to show you considered environmental protection and seriously considered it, not just it was a thought that went away, that you were continuously considering the environment throughout the course of the incident. And you have to be able to justify your actions if some pollution has entered the local environment, or the local environment has become polluted as a result of that fire and the fire service's actions. You must be able to justify that.
Okay, Bernie, thank you very much for your time. I mean, your what you've been talking about today, I think, is what's happening in a lot of countries in Europe, and it'd be very interesting to see how this is going to develop in the future.
Oh, thanks for your time. This is a really interesting subject.
Yeah.
It's one we should all keep an eye on, because with sustainability, with new building materials coming out and the built environment having to change, this isn't going away. It's only going to become even more important to us all. So really glad to have the time to be able to talk to you about it.
Great, thanks Bernie.
Thank
We'll
you.
see you later.
Thank you. See you soon. Bye.
Bye.
That was Bernie Higgins from the United Kingdom. He gave us some insight into how they work in the UK with water runoff. It's become an increasingly important issue there in Sweden and possibly other countries in Europe. And he gave us the 5 different ways in which the National Operation Guidance gives the firefighters ways in which they can work. And you can see those on the screen now. To actually contain the water, that's a very difficult task. But what we can work with quite easily is to reduce the amount of water we use, and in such a way that maybe we don't even need to consider this. And that's where Cobra comes in, because it's a tool that only uses 60 litres of water a minute. It creates a very fine mist, so instead of lots of water ineffectively, it's a smaller amount of water that's used effectively. And fine water mist travelling at a high speed, it's about, how fast is it, Lena? Do you remember?
Yeah, close to the nozzle,
Yeah.
I would say it's approximately 200 meters per second,
Yep. So it's
causing a great turbulence.
Yeah,
Sorry.
it's a very fine mist travelling very, very fast. So those 2 factors make it very, very effective at absorbing the heat. And as I said, creates a large amount of turbulence. And one of the other effects is that if we have this transition from water to steam, it actually means that the percentage of oxygen in the air reduces, and we all know that the fire requires oxygen. Yes. So that's another effect. So it's this fine water mist that turns into steam, and that's what we see on this picture here, the gas laws. Now you're the smart one, Lena.
You keep saying that.
So if you could explain this this picture to us.
Okay, so this is the ideal gas law, telling us how much steam we will get out of 1 liter of water. And at different temperatures we get a different efficiency from the a different, what do you say, different amount of it will get faster.
Yeah.
It will evaporate faster.
Yeah.
Sorry, I'm tripping over the words. So as we can see in this picture, at 100 degrees, 1 liter of water will turn to approximately 1.7 cubic meters of steam.
Yep.
And the same amount at 600 degrees will be 4 cubic meters of steam. So it's okay, so it's a small amount of water with a big effect and little damage.
Yeah, and that ties in with what we see practically as well, because we know that if we're talking about quite a tightly sealed space, if you say like an attic, which is the typical fire to use Cobra on, we always so if we've got lots of heat that's enclosed, that's when we usually get the best effect. And that ties in with the gas law here, because then we are talking 600, 700, 800 degrees. The gas can't go anywhere, so it pushes out into every corner of the attic, and that's why we get such a good effect. It will work if there is openings, if there's a window or a door, but it doesn't work as effectively. That's the optimum. High temperatures in an enclosed space. That's the science behind it. I don't really understand the bit to the right. Maybe you do, but we don't need to go into that.
We'll leave it there.
We'll leave it there. And what's this one?
Okay, this is a comparison that Rice did. It compares Cobra to enhanced low pressure, and we can see at 400 degrees the Cobra is very efficient, very rapid at lowering the temperature. After 100 seconds, you can see in the horizontal axis, after 100 seconds we got down to approximately 220 degrees with Cobra, and at 320 degrees approximately with enhanced low pressure system.
And RISE, who are they?
RISE is a Swedish research institute.
Yes. So we've done quite a bit of work with them before. It's the National Testing Laboratory. So
Yes.
we've sent quite a lot of the test material to them. Okay, so what we can see is that the Cobra is much more effective at lowering the temperature with less water.
Yes.
And that's the theme of what we're talking about today.
What do we see here?
What we see here is two graphs that compares the Cobra against the Fognal. We have the Cobra to the left, the Fognal to the right. It's a similar fire loading, both fires, and the attacks were made at exactly 178 seconds, I think. What you can see to the left is that there's a rapid decline in the temperature from the Cobra using the 60 litres of water. The Fognal was using a little bit more, 75 litres a minute, and we see a much slower decline in the temperature, and it even flattens out. It gets to a level where it can't take the energy from the fire anymore. And how long they did the test, I don't know. They stopped it about 250 seconds, I think. So what we see again, it's much more effective with less water, and we also have a problem with the Fognals, and that's they're very often forgotten because you put the Fognal in. It's an advantage in that you can use it and then go and do something else, especially if there's limited number of firefighters. But the problem is when you go to do something else, you very often forget about it. And this leads to both water damage and possibly even water runoff. And I think most firefighters have been to incidents where the cellar has been turned into a swimming pool. And this is one of the tools that causes that. And then water damage, which is what we just mentioned. This graph compares a standard nozzle, which is the black line, and then we have the red line, which is the Cobra. So what they found from this test is that the Cobra at 2 to 250 degrees was 80% efficient, and that means that 20% of the water ended up on the walls and the floors. With the standard nozzle, that was almost reversed, that 20% was used effectively and 80% was on the walls and the floors. And at a larger instant, once that starts to collect on the floor, it's going to start flowing out of the building as well. So that's just two comparisons with the Fognal and the Cobra and the standard nozzle and the Cobra. And now we're going to watch a video. This is a video from Holland. Yes. From Holland, or the Netherlands, as I should say. This is from our friend Olaf. So thank you very much for this video. And this will show a car fire extinguished using Cobra. So they've loaded the van with pallets and rubbish just to get a very good fire, lots of heat. Normally car fires, this is a particularly good example, speaking from my own experience, where we really didn't pay any attention to how much water we used. So the Cobra's starting to cut now, and this is going to go really quickly when it comes through the side of the van. Just about now. There we are. So it's cut through, and the fire is already extinguished. It took about it looked like it took about a second. The water that was used before, when it started to cut, that was just clean water, so it wasn't really a problem. So because it was so hot inside the van, it was almost like an oven. And so the 1 litre of water, 2 litres of water we used, that was turned to 3.5 cubic meters of steam, as we spoke about when we showed you the gas law slide. And if you think 3.5 cubic meters of steam in this small van, it just fills it completely, and that's why we had such a quick effect. So a very good example, very simple example as to how we can use water effectively and efficiently, and to prevent excessive water runoff.
Perfect.
So that's the end of today's webinar.
Yeah.
Thank you very much for watching. Send in your comments and any questions, and we'll be happy to answer them. Thank you.
Thank you.